Challenge of the day. Determine the missing interior angle of a triangle if it is known that two of them measure 120 degrees and 59 degrees. That's how I started my morning. And most people were answering that the answer was 1 degree, and that's fine. In fact, that's the correct answer. The other angle measures 1 degree. But there was one answer that intrigued me quite a bit, which is the following. They told me arithmetically, it's 1 degree, right? But then they say, but it's not possible for such a triangle to be formed. And the truth is, as I said, it intrigued me quite a bit, because this wasn't the only person who said this. There were other people who were commenting that indeed, we can't draw a triangle with such angles. So, the idea here is, can you construct a triangle that has internal angles of 120 degrees, 59 degrees, and 1 degree? Let's find out. Look, come a little closer, because we're going to do some calculations to see if it's actually possible. Look, I'm going to make a sketch of the triangle. I'm drawing it here. But this isn't the real triangle, right? Let's say, for example, this angle measures 120 degrees right here. Let's say this other angle, I'm going to put it over here, is the one that measures 59 degrees. And then, well, this other angle will be the one that measures 1 degree. Okay, now, let's say, for example, that this side, this one over here, let's say it measures, let's say 10 centimeters. Okay, or 10 units, it doesn't really matter. We really don't know how long this side is, but I'm assuming it's 10 centimeters. Keep in mind, I can say it measures whatever I want. Okay, because the only condition we have is that the internal angles are the ones I have marked here. So the other two sides have to match the side I'm proposing. I'm going to say this side measures B, I don't know how much it is, and this other side over here measures C. Okay, well, this one here, I'm going to say it's my side, sorry, that it measures A. Now we're going to state the law of sines. The law of sines basically tells me that if I have side A over the sine of angle A, this has to be the same as side B over the sine of angle B. And, well, at the same time, this has to be the same as side C over the sine of angle C. So, as you can see, here we already have the angles, so we could calculate the sine, of each of the angles. Also, I'm proposing a value here that, I insist, can be whatever I want. Okay. So they're really going to depend on the one I choose. So let's start substituting some values. For example, suppose I want to calculate AB. I already know it measures 10. I can also calculate the sine of A. In this case, it would have to be its opposite angle. So I would have to calculate the sine of 120. I don't have AB, but I do have the sine of B, which in this case would be the sine of 59. So let's use our calculator to do this operation, which means right now I would only be using this part here. Alright, so come on, let's substitute. I have 10, which is A, over the sine of A, which in this case we had agreed on, which has to be the sine of 120 degrees. It has to be the same as B, which I don't know. Over the sine of B, in this case, it would have to be the sine of the angle that's opposite the side, right? So, the sine of 59. And from here, we're just going to solve for AB using this sine of 59. We can move it over to the other side, so that I'll have 10 over sine of 120 multiplied by sine of 59 degrees. Well, this should be the value of B. Alright, let's put this operation into the calculator here. In this case, press the fraction button and enter 10. We go down with the arrow and enter sine of 120. Close the parenthesis, move over, and enter times sine of 59. There it is. We hit execute, and it's telling me that it's about 9.8977. Okay, I'm going to use a lot of decimal places, since we actually have a pretty small angle, so we need to use a lot of decimals. Otherwise, it won't be very accurate. Okay, so let's use 4 decimal places. It's 89.77, but as you can see, there are actually more decimals, right? In fact, it doesn't mean that these are the only ones. There could actually be more. But let's leave it like this. Okay, with this number of decimals. Well, let's not forget that here we're considering A equals 10. And in this case, this would be the value of B. And I'll also note here that it's in centimeters. I can do this same process now, for example, by equating this here with this over here, right? I mean, it's exactly the same. So, let me write it down again really quickly. So, the left side stays exactly the same as it was. Sine, 10 divided by sine of 120 degrees. It has to be the same as before. C, which I don't know either, divided by the sine of C. In this case, C must be, angle C has to be this one right here, right? So would it be like this? Sine of 1 degree we solve for C. And in this case, I would have 10 divided by sine of 120 degrees times sine of 1 degree, which equals C. Okay, let's do this operation here. In this case, we're just going to change it. And instead of leaving the 59, we're going to put a 1, right? It's exactly the same. And I'm getting that this side should measure. Remember, use the measurement I set and fixed. It should measure 0.2015 approximately. These are also centimeters. All right, now we have the measurements. The triangle, which has internal angles of 1 degree, 120 degrees, and 59 degrees, could measure 10 centimeters, 9.89 centimeters approximately, and 0.2015 centimeters approximately. Okay, that would be one possible combination. And I say one possible combination because all the multiples or submultiples could be of these numbers. Well, they will give us other triangles. That is, similar triangles that also meet the conditions. For example, I could divide this side by 2, and the other sides would also be divided by 2, since all the triangles we get are similar. All right, so now let's go directly over here. This is the GeoGebra page, and we're going to draw the triangle. This might get a bit complicated, so stay with me as I draw. First, I'll draw side A, which is 10 centimeters. To do this, we'll go here where it says segment. I put a little dot here, and now I go to the 10 and put the other dot. Now we have the first segment, which is the one I'm marking. That's why I made it 10 centimeters, so it fits perfectly. On the screen, I can enlarge it so you can see better. Okay, and let me remove the grid right now. Sorry, moving the axes so they're not in the way. That's better, right? Cleaner. Now, we already know that to draw a triangle with more precise measurements, we can do it with circles, right? So we click here, and I'm going to select this first one that says circumference, given its center and a point. Okay, so let's put it here. For example, and now. Sorry, I chose the wrong one. Let me go back a bit. It was this other one, circumference with center and radius. Okay, let's click it, and now we have to specify the radius. So in this case, what I have to do is enter the other measurement. The other measurement was, for example, 0.2015, right? 2015. Well, that's the value we got for C, so we enter it. And here it is. Look how small it turned out. Now I do something similar at this other vertex, which will be a vertex of the triangle. Now we'll enter the other measurement, which was 9.8977. We click OK, and there it is. Now at the intersection, let's locate it. Here it is. Let's put a little dot. And this point I just placed here is the one that's going to help me draw my triangle. So the triangle is going to go from here to here, and then this one has to go all the way over here. That's where the triangle will be, with the mentioned angles. Let's check if that's true. Go here, select polygon, and take it. So the 3 points I just had, which would be point B, point C, let's see. Here it's going to be a little difficult. All right, there it is. I'll move over to point A, and then from here, let me zoom in. I'll move over to point B again. All right, let me adjust it so you can see it clearly. Someone noted in the comments it would look like a needle, and it really does. Can you tell what kind of triangle it is? I'll move this so you can see it better. Now you see the whole thing, right? All right, so this doesn't get in my way. What do you think? If we hide the object, which in this case is the circle, well, the circumference, and also this other circumference, let's hide them so that we only have our triangle left. Here comes the golden test. What is the golden test? Well, when I ask GeoGebra to tell me what the measures of the internal angles are, they have to be the ones we mentioned. No. Let's see if it's true. Let's apply it here where it says, yee. We click inside and look. Here we can already see that in fact this angle, look here, it does measure cow 1. Let's check this one over here. This one says it measures 120.01, and this one says it measures 58.99, which means 59 degrees. As you can see, we did have it right, didn't we? Here we have about 59 roughly, right? Here it's around 120, and here we got 1. Well, it's not giving us exactly 120 and exactly 60, because I didn't really use all the decimals either. But the more decimals we use, obviously, the more accurate our result will be. But well, what more could you want, right? With this, we can see that we were indeed able to construct our triangle. And well, for those people who were saying it couldn't be done, here we are proving that, indeed, it can be done. Now, if you ask me, can we do it with a ruler and compass? Well, yes, we could. But honestly, it would be quite complicated. As you can see, because the precision we can achieve when we use, well, I don't have a ruler here, but when we use a ruler, at best, we can really only get to a precision of millimeters. But as you can see here, I put it to 4 decimal places. This means that I'm dividing the centimeter by 10,000. And obviously, I can't really do that, right? For that reason, we can't be that precise. So, if the person meant that we can't physically do it with a ruler and compass, then they were right. With a ruler and compass, it would be very complicated unless we used a very large sheet of paper with a scale that made it possible. No, but if we want to do it here, directly in our notebook, then we couldn't, since we couldn't be that exact with the measurements. But it is possible. It is possible to do it.